So 6.1.1 cos x plus y, we can rewrite that as cos x minus y. Now that's the exact same thing as this. And what this helps us to do, it helps us to use the expansion that they've given us here. So if we take this exactly the same as this expansion, so if we look at this expansion that they gave us, the identity they've given us, we see that we took cos of the first term in the bracket here and cos of the second one, and we do the exact same thing now. And the only change here will be, which we'll see just now, we'll say it's cos x cos minus y. Okay, using this exact same thing, which we've taken that and that. So we've got cos x and cos minus y. And you see there's a plus in between here. So we're going to put the plus there. And we're going to say sine. Now we're using the stuff that's here. Sine x, sine minus y. Okay, so just to recap, we need to know how to reduce this cos minus y and sine minus y using our cast diagram. If you need help, you can click the link in the top right hand corner for the video, the detailed video on reduction. So what we can do here is basically add 360 to this, and we will get cos 360 minus y, which we know using our cast diagram, which reduces to cos y. In fact, let's just do that quickly. We have the cast diagram and the reduction. We have A, S, T, C. In the fourth quadrant, we know the reduction is 360 minus theta. In this case, when we add 360, we're going to get cos 360 minus y. Cos is going to be positive. So that reduces. So let's just write the first one as is cos x. This reduces to cos y. Very simple. Now, the problem here is when we look at this, sine minus y, we've realized that, again, when we add 360 to this, we're going to get sine 360 minus y. And in the fourth quadrant, sine is negative. So we're going to get plus sine x times negative sine y using deduction. And here we see a positive times a negative will give us a negative. So let's just write this up. There's nothing else we can do here. Cos x, cos y, and positive times a negative is going to give us a negative equals to sine x, negative sine x, sine y. Okay, I hope that makes sense. But once again, if you guys don't understand something or you're not clear on something, please leave a comment below and I will assist you guys. So yeah, the whole thing here was to use exactly what they've given us. And how do we change this negative y into a positive y? What we did here, we took out a negative, right? So we wrote down exactly what they wanted us to calculate, which was cos x plus y. And we rewrote this positive y as a negative y, okay? Okay, let's move on to the next question. Okay, 6.1.2, and this is where things start to get a little bit interesting. So let's go through this. Okay. Okay, let's look at this. And we see that this is, okay, so this we want us to prove this identity. So we're going to start off with the left-hand side. So when approaching identities, it's also beneficial to look at the right-hand side and to have an understanding of what we're actually going to do or to guide us. So I'm not aware if you guys know your co-ratios. Please, if you know please write down your co-ratios here on the formula sheet because they do not appear in the formula sheet. You need to know them. So write them down before you start. Because they're very, very important. So when we look at this question, when we look at the right-hand side, okay, we have tan x plus y. So in the back of our mind, we need to know that if we look at the left-hand side, we see we only have sine and we have cos. There's no tans found there. So we know that eventually we're going to have to get a sine x plus y over a cos x plus y in order to get our right-hand side, which is a tan x plus y. And how we do that is we basically have to reduce everything here and hope that we get it into one of these forms where we can get a sine x plus y over a cos x plus y. So let's get going. So using co-ratios, we know that cos 90 minus x, if you guys aren't aware of co-ratios, I'm just going to write them down here quickly so you guys know. Firstly, you get sine 90 minus x is equal to cos x. You've got cos 90 minus x is equal to sine x. Then we have, that's the first one, that's the second one. Then we have sine 90 plus x is equal to cos x. And lastly, we have cos 90 plus, that's a plus here, x is equal to negative sine x. So let's use that. So here we have cos 90 minus x, that reduces to sine x. Here we have cos y, we're just going to leave that as it is because there's nothing ready to reduce there. Then we look at the next term here, and we have sine minus y, and that we know when we add 360 becomes sine 360 minus y. And our cast diagram, we have CAST, 360 minus y, 360 minus theta is here, 180 plus theta is here, 180 minus theta is here. So we see that 360 minus theta is in the quadrant, the fourth quadrant where only cos is positive. So we know that sine is negative here. So I'm going to say that's plus, and I put this in the bracket here, minus sine y. That reduces to minus sine y. Here we have cos 180 plus x, and we see 180 plus x will be found in our third quadrant. In that quadrant, only tan is positive. So here that's going to be a negative cos x. Okay, as we can see, it's starting to sort of look like these expansions. So that's a good sign. Then we look at our denominator, we have cos x, can't reduce that. We have cos 360 plus y. Now, here we can simply subtract 360 and we'll be left with cos y. Remember, when reducing angles, we can add 360 or subtract 360 as many times as we like. So let's go on to the next one. Here we have sine 360 minus x. Once again, we know that's in our fourth quadrant. Sine is negative there, so it's going to be a negative sine x. And we have sine y, and that's just sine y. There's nothing much we can do there. So then let's just write this out nicely. We're left with sine x cos y. Here we have a negative and a negative, which will reduce to a positive, and we're going to write that as plus cos x sine x. The reason I'm writing cos x first, remember I said we're probably going to have to end up with a sine x plus y on the top and a cos x plus y at the bottom. That's the only way we're going to end up with our tan x plus y. And when we see this, we sort of already understand what's going on. And we now need to realize that we are trying to find the reverse of this sine expansion on the top. And which expansion are we looking at? X plus y. So we're looking at this expansion over here. So you see we've got sine x, cos y, cos x. Oh, sorry, this is sine y, right? And on the bottom, now we are going to rewrite the bottom as well. We're going to leave the first one exactly as it is because we want this to be a cos expansion, and the cos expansions has a cos and a cos, and then a sine and a sine. So we have that cos x, cos y. Then let us look at this. We have a positive here times the negative times the positive again. So that's going to be a negative minus, and we want to write that as sine x, sine y. Now, using our expansions here, we can see our sine expansion and the cos expansion. We can see that the top is going to reduce to sine x plus y, and the bottom cos x plus y, and that is tan x plus y, which is equal to our right hand side. Yeah, I hope that makes sense. And then now we're going to move on to the next question, which is 6.2. And we have something here that doesn't look very nice, but it's actually quite simple. So we look at this question, say given f of x equals to square root of 6 sine squared x minus 11 cos 90 plus x plus 7. We must solve for x in interval 0 to 360. 0 to 360 if f of x is equal to 2. So if f of x is equal to 2, then this becomes an equation. So I'm just going to swap the order. So basically we have 6 sine squared x minus 11 cos 90 plus x plus 7 equals to, no, sorry, not 0, equals to 2, because they told us that f of x is equal to 2. Now, we see we have a square root here. So the first thing we're going to do is simply square both sides. And when we do that, the square root will be gone from the side. So we're going to say now that's 6 sine squared x minus 11. Okay, so look at this. We want everything in terms of x. You see we have a minus 11 cos 90 plus x. Using the co-ratios, the co-ratio that says that cos 90 plus x is equal to negative sine x. So we're just going to replace that by to negative sine x plus 7 is equal to 4. So now I'm just going to rewrite this side. 6 sine squared x. Negative times a negative gives us a positive 11 sine x plus 7. And now we can see that this is a trinomial because we got a squared x and we got an x and we've got a coefficient here. Sorry, a constant. Then I'm going to subtract the 4 from both sides. So it'll be, or move the 4 from that side. The positive 4 becomes a negative 4 equals to 0. Okay, and let's just, since we explained this, let's just rewrite this one more time. We've got 6 sine squared x plus 11 sine x plus 3 is equal to 0. And this is a trinomial. Okay, so what we're going to do here, since this is a trinomial, we're going to now factorize this. And yeah, there's no common factor here, so we have to factorize. And when we find the factors, by factorizing this trinomial, we're left with 3 sine x plus 1, 2 sine x plus 3, and that's equal to 0. If you guys are confused on how to factorize this, it's the same as as factorizing a normal trinomial in algebra. And in algebra, this would look like 6x squared plus 11x plus 3. Now, it's just that the sign is there, so we don't treat the sign any differently. We just factorize this as if we wanted to factorize this in algebra. So it'll be 3x plus 1 as 2x plus 3. Same thing. But here we're just adding on the sign. So hope that doesn't confuse you guys. And you realize it's exactly the same thing. So again, when we're solving this, that's where the difference comes in. When we factorize this, we're now left with this, and then now if we solve the equation, we're going to say 3 sine x plus 1 equals 0, or 2 sine x plus 3 equals to 0. And we're going to have here sine x is equal to negative 1 over 3, or um, sine x is equal to negative 3 over 2. And we know that there's going to be no solution here. The reason there's going to be no solution here, if we understand our trig functions, right? When we have a sine x, so this is 1 sine x, we know that it's going to look like that. The maximum is going to be 1, and the minimum is going to be negative 1. Now, this is negative 3 over 2, and that's going to be found here. And the sine graph, this sine graph, doesn't exist at that point, so there's no solution here. This, however, does exist, right? This does exist. So what we need to find there is we need to find the general solution. Okay, and we need to find a reference angle first of all. So to find the reference angle, we press shift sign on our calculator and we enter the positive value here, which is 1 over 3. So reference angle, when we do that, we're going to get 19.47 degrees. Okay, and that's not our solution. So then now when we look at our cast diagram, okay, and really quickly, 180 minus theta, 180 plus theta, 360 minus theta, STC there. Okay, we need to look at where sine is now negative. And sine is negative here in the third quadrant, and it's negative in the fourth quadrant. So we add, to find our x values, we're going to add the reference angle here in the third quadrant to 180. So we're going to say x is equal to 180 degrees plus 19.47, and that's going to be, okay, let's actually come down. Yeah. And yeah, so we're going to be left with x is equal to 199.47 degrees. And we also have the other situation where sine is negative, which is in the fourth quadrant, and we have x is going to be equal to 360 minus our reference angle, again, 19.47. And we're going to have x is equal to 340.53 degrees. I hope you guys understand this as well. Okay, then now we're going to move on to the next question. Let us clear this out. Let's look at question 6.3. We see here we have a function, but it's not in a form that we can understand where it's simply a sort of like a simple sine or cos function. We have a sine squared x, which we aren't really familiar in how to deal with it. So we need to try and make this into a form where we understand. So let's write this on. G of x is equal to 4 minus 8 sine squared x over 3. So the first thing we're going to do is we look at this and we don't really know what to do here because this doesn't look much like a function that we can recognize. So what we're going to do is we're going to do the only thing that we can do here, and it's factorize, and we see that we can take out 4 as a common factor here. So let's take it in the numerator. 4 as a common factor, if 1 minus 2 sine square x. And automatically we can see, oh, okay, that looks exactly the same as this in our formula sheet. Cos 2 alpha is equal to 1 minus 2 sine squared alpha. So here we have x, so we can change that now into 4 cos 2x over 3. And this is something that we can recognize. The reason I say that is because we can rewrite that as 4 over 3 cos 2x. Now, just like in 6.2, we need to have knowledge of our trig functions here. Let's look at a standard cost function. Looks something like that. A standard cost function will have a maximum of 1 and a minimum of negative 1. And we get that. Where do we get this 1 from? If you look at the mother function for cos x, we get the 1 from here. From here, our a value. So when we look at this question, although the 2x is there, that doesn't make a difference. That doesn't affect the maximum and the minimum. So when we look at this, in place of 1, we have a 4 over 3. So the maximum value of g is equal to 4 over 3. Because if I had to draw this function, it's going to look at, oh, that looks terrible. So if you have to draw this function, what's actually going to happen here is it's going to look exactly the same. Obviously, I'm not giving the x values here, but the maximum again is going to be 4 over 3, and our minimum is going to be negative 4 over 3. Okay, I hope that makes sense as well. Now let's look at the last question. And I'm just going to include, okay guys, let's look at the last question, and I'm just going to include like a short sort of lesson here on trig functions. So let's look at that. Let's look at that. So normally we have a normal cost function, okay? Something like that. And normally the period of this cost function would be 360. But in the question that we have here, we have 4 over 3 cos 2x. Now this means that the period is halved. So whereas this usually would have been 360, now it's 180. And if we look at the period of this question, 0 to 360, we can see that we're going to have another full cycle. So let's just extend this. And this is going to be now 360. So they want to know the smallest value of x. Now this is our x-axis. Now they want the smallest value of x for where we're going to have a maximum value. Now for a maximum value, it's very important. We need to understand, we need to have a portion going up and a portion coming down. Now we need to have both of these. We need to have this part on the left and this part on the right. Now in the given domain, we could argue that where x is equal to 0 is also a maximum value, but it isn't, because we're very strict in our domain here that it starts from 0. Unfortunately, we don't have the part that's going down here because that doesn't exist according to the domain that we're given. So in the domain that we're given, the earliest maximum value is found here at 180. Okay, I didn't draw this perfectly, guys, not drawn to scale, definitely not, as you can see, but this is our first maximum value. So in the domain, the only maximum value, in fact, is x is equal to 180 degrees. Okay, guys, I hope this video helped. If you guys have any questions or you're unclear about something, please leave a comment below and I will assist you guys. And if you guys are looking for personal lessons, please contact the number found in the description or the number that's on the screen. Thank you.